Hello, you're watching Exo Photography. I was thinking of making a update today where I'm going to talk a little bit about this one. It's a weather station, Arduino Weather Station I have made. So let's take a closer look and see how it works and how I have built it. Hello, so I'm standing here besides the controller box. It contains a Arduino microprocessor which you can program yourself. Just above it it's a sparkfun weather meter kit which contains a anemometer which measures the wind speed and a dial to measure from what direction the wind is coming. It also has a, I don't know if you can see it, it's a meter for measuring how much rain it's coming. Let's see if we can take a closer look to what's inside this box here. I don't know if you can see it, but you can see the red shield, the weather meter shield from sparkfun. It sits just above the Arduino shield inside there. Everything is connected via USB cable to the computers inside. And here you can see the rain gauge, the wind direction meter and the anemometer. So everything goes via a USB cable inside the observatory. So we can go inside and take a closer look to what it looks like. We're inside my observatory and we're going to have a look at how the controller software looks like. It connects via USB, as I mentioned before. You just pick up the right COM port and click connect, then you can choose the update interval. Right now I'm using 15-second updates. So this thing measures ambient temperature, sky temperature, and the difference between the sky temperature and the ground temperatures. The reason it does that is because we want to see if there are clouds or no clouds, and this program writes a boltwood file, so my sequence program can read that file and determine if the weather is okay to photograph, to start a sequence, or if the weather is so bad that it's no point taking pictures. So let's dig in. I will make a screen recording and let's see how it works. Okay, so let's have a look at what this is. So first of all, I want to give a shout out to Mano Kushik. Excuse me for the pronunciation. He has written the code for this Arduino observance condition. So if you are visiting his GitHub, you can read through the PDF file for how to build it, what parts you need. Actually, we can have a quick look at what it says. It's quite easy to build one yourself. What you need is one Arduino, the sparkfun weather shield, the weather meters, some RJ11 connectors, For the cloud temperature, you need a sensor which is called MLX9614. It's an infrared contact glass temperature sensor. You need some resistors, some shrink tube, some cables, a box, some cable glands. So basically this PDF tells you exactly what you have to do. So it's quite fun project if you haven't been fiddling with Arduinos before. It's a good project to start off with. But let's look how to see what it looks like. So this is the main window when you install the software on your computer. It's the Arduino Weather Station. Basically you choose the proper ASCOM driver, which also is included in the GitHub. You choose what COM port connects, choose what update interval, if you want metric, or what kind of units you want to use. So let's get on with it. It measures the ambient temperature. This has some drawback because the weather shield is inside a weatherproof project box. It actually reads a bit higher than what it actually is, and my project box sits in the sun, so you can see the temperature here is some degrees higher than it should be. The sky temperature is right now -5 degrees Celsius. It measures the cloud base, and if I look outside my window right now, I can see that the clouds are just about to roll in, so we might see some change during when I'm recording this. The difference between the ground temperature and the cloud temperature is 31 degrees. All above about 24 to 26 degrees is considered as a clear sky. So in the wind tab we can see the current wind speed. Right now it's measuring 1.3 meters per second. The wind direction, it's quite hard to tell in what direction. 45 degrees should be somewhere about northeast. The wind gust, I don't actually know how the wind gust is difference, the difference between wind speed and wind gust is, but the highest recorded since the last time I opened this software is 10 meters per second. So let's go on to the cloud tab. As it indicated on the temperature, the difference is higher than 26 degrees. So it measures 0 clouds, and that is correct as to what I'm looking at right now outside my window. No rain. The sky brightness, it's a sensor on the weather shield, so it measures how bright it is. In the settings you can also, in the driver settings, you can also set the proper values, so when the twilight begins and etc. The last tab is the humidity and pressure. So the humidity right now inside the project box is 24%, and the dew point, it calculates the dew points in regard to humidity and the temperature. Right now it's 4.17 degrees, and also it measures the pressure. So this software wouldn't be as good as it is if it were for the ability to write a boltwood file. So let's see if I can find that. let's see where it is located. No, actually I haven't activated that yet, so I might show you later on. But the reason it writes a boltwood file is that that kind of text file is readable from several sequencing software. As of mine, I am running the Astrosystem Austria sequence, which can read boltwood. I believe Sequence Generator Pro can read boltwood as well, and ACP, etc. There are a lot of programs. You have Nina, you have, I don't know about the ASI specific softwares, if that has the ability to read weather data. But this hardware and software is very useful for when you have a observatory which is running autonomously. So you need to have some surveillance if it starts to rain or the clouds are rolling in. And it's a fun project to begin with, the Arduino project, if you haven't done it before. So that's it for now. I'm starting to hope that the nights will be a bit darker here in Sweden, because it has been 2 months of brightness, so I haven't been able to test the new focuser properly and the collimation, etc. I really hope that my last changes will be adequate, so I have pinpoint stars across the illuminated field. So this is it for now. If you like my videos, please like, share, and subscribe to my channel. Yeah, have a good one. Bye.